This is the video on acceleration. So remember in these videos that there are going to be two codes, right? One is a written code that'll appear on the screen. The other is a verbal code said by myself at some point in the video. Each code will be 3 numbers, and you will need all the codes in order to move on with that homework assignment. So when you're looking at these notes and these slides, remember what's in green is going to be like the bulleted points, the important stuff. The rest, yeah, it's just as important, and you can write that down. But the rest is going to help you out, just understand the topics. All right, so this is that written code. I would recommend you write this down somewhere. All right, so here's just a quick assignment, right? Sort of like a riddle, right? So let me move this down. Here we go. So here's a riddle. 2 birds leave the same tree at the same time. They both fly at 10 kilometers per hour, so same speed, for 5 minutes, same time, yet they don't end up at the same place. How is this possible? So the answer is they didn't fly in the same direction, right? Direction is going to matter in some of these problems, right? So here's velocity. Remember, velocity is how fast and which direction an object is traveling. So measured the same way as speed, it has the same units, meters per second. Now, it is a vector quantity. Vector has both magnitude and direction. So if you look over here, I've got 2 cars, right? One's going to the right, one's going to the left. They're both going the same speed, right? 25 meters per second. Now, one is going in the positive direction, positive 25 meters per second, and the one is going in the negative direction, negative 25 meters per second. Direction does matter. So let's go ahead and look at acceleration. Acceleration is how quickly something changes its velocity. So this is the equation, and you can see I put a little triangle up there to help you calculate it. So it's the acceleration equals that final velocity, how fast it's going at the end, minus the initial velocity, how fast it's going in the beginning, and you divide it by that time interval in which that acceleration takes place. So it is a vector quantity, which means the direction does matter. There are 3 ways to accelerate. Number 1, you can speed up. Now, if you're speeding up, the acceleration is going to be in the same direction as the velocity. Now, you can slow down. And if you're slowing down, the acceleration will be in the opposite direction of the velocity. And you can also turn, which means you're just changing direction. Now, the unit for acceleration is meters per second squared. So basically, how much faster every second, or faster or slower, are you getting every second? So it's basically meters per second, meters per second squared. If you don't quite understand that, that's fine. Just know the unit for acceleration is meters per second squared. So let's answer this question. Could you accelerate without changing speed? So let's look at a car, right? So let's look at the gas pedal, the brake pedal, and the steering wheel. Which of these controls cause a change in speed? Well, the gas pedal and the brake pedal change the speed of a car. Now, which control or controls will always cause a change in velocity, but not necessarily a change in speed? It's going to be the steering wheel. The steering wheel will change the velocity without necessarily changing the speed. Because remember, velocity is speed plus direction. So you could be going the same speed but changing your direction. If you're changing your direction, you're also changing your velocity. So which of these controls cause an acceleration? The gas pedal, the brake pedal, and the steering wheel will all cause an acceleration because they will either change the speed or change the direction of the car. One speeds it up, one slows it down, the other turns. Those are the 3 ways to accelerate: speed up, slow down, and turn. So let's get some practice calculating acceleration. So here's a question. A car is initially at rest and speeds up for 10 seconds until it reaches a speed of 30 meters per second. What is the acceleration? So first thing I do is I look at this triangle. I mean, you can use the equation as well, but I'm going to cover up the variable that I want to calculate, and that's acceleration. So my acceleration is my change in the velocity divided by time. So what I do is I think of it as telling a story, right? The final velocity is how fast this object is traveling at the end of the story. The initial velocity is how fast that object is traveling at the beginning of the story. So all I do is I plug everything in. It ends at 30 meters per second. It started at 0 at rest, and this change in velocity took place over 10 seconds. Plug everything in, and I get 3 meters per second squared. So let's look at another problem here. Right. So a car with an initial speed of 20 meters per second accelerates at a rate of 16 meters per second squared until it reaches its final velocity of 100 meters per second. How long will it take to reach that velocity? All right, so first thing I got to do is figure out what this question is asking me to find and cover up what I'm looking for. It's asking me how long, so I'm looking for time. So time equals your change into velocity divided by the acceleration. So I plug in what I know. Now think of it this way. Remember, velocity, like I'm telling a story. At the end of the story, it's going 100 meters per second. At the beginning, it's going 20. 100 minus 20 divided by 16, 5 seconds. So let's take a look at this last one. Now, the last one is a little bit tricky, right? A car traveling at 200 meters per second slows down with an acceleration of -8 meters per second. What was the car's velocity after 10 seconds? So first I got to ask myself is what am I being asked to find? The final velocity. So what I have to do is I cover up my change in velocity. Change in velocity equals acceleration times time. Now I plug in what I know. Now here's the thing. This requires that extra algebraic step. -8 times 10 is -80. I'm looking for the final velocity. So I have to get final velocity by itself. So I have to add the 200 because I'm subtracting 200. -8 times 10 plus 200 gets you 120 meters per second. And there is one other problem that I can give you that's a little bit trickier is if you're looking for the initial velocity. But it's the same process, right? The same process is you cover up the change in velocity, it equals acceleration times time. It's just that you have to subtract the final velocity and then divide by -1. That is that's the tricky part, right? That's the trickier one, right? All right. So at this time, I'll go ahead and give you the verbal code. The verbal code is 558. I say that again. The verbal code is 558. So in order to reinforce this lessons, what we did was we did the acceleration class activity. Now on this, there were several different things. We're looking at, you can see that in the little thumbnail, we're looking at those oil drop diagrams, right? Where you have to say, well, is it speeding up? Is it slowing down? What direction is the velocity? And what direction is the acceleration going in? Now, we did this simulation. This is like a physics classroom one. Name that motion. So this was looking at different different scenarios and naming that motion, right? So this is that second one. And we did a lab in which we took a cart and rolled it down the different ramps. So we were taking these carts and we were measuring at different points in the ramp how long did it take that car to travel 1 centimeter, and then using those velocities, we were able to calculate the acceleration of that cart as it traveled down the ramp. So, once again, as a final thought, there's too much unknown in the universe to take a break from learning. Get out there and question everything.